get started here, I want to start by thanking everybody for coming and welcome to everyone to the Sierra Club, Massachusetts Sierra Club Forest Protection Team's month. This is our monthly meeting. My name is Lynn Mann, and I'm the founder and a co-leader along with Nancy Poland, who's also on the call of the team, and Celeste is our fearless team coordinator that we couldn't live without. Um, Tonight, we're super excited to have a fabulous guest speaker, Shelby Perry. And as Shelby is the director of the Wildlands Ecology Program at Northeast Wilderness Trust, also known as NEWT, appropriately known as NEWT. She is a frequent speaker around the Northeast on topics of wildlands, rewilding, and old forests. And I think we're all here because of our love of forests, whether we've been working in forest preservation or just enjoy a peaceful walk through the woods. Shelby's enthusiasm for forests is delightful and contagious. Um, I've learned about her through Bob and Monica Leverett, who are also on this call and shared a video of this talk that she did, and I couldn't pass it up. So I'm so happy that she's here. Her talk is both informative and entertaining, and regardless of our relationship to forests or our age or our location. Shelby's going to illustrate in a unique way how passive management, or the practice standing back and letting nature direct the ebb and flow of life, benefits both humans and non-humans, and why we should preserve old forests for the future, even if we might not live to see them ourselves, which a lot of us won't, but we want to do that anyway. After Shelby's presentation, we'll have time for questions and answers, which will be facilitated by Celeste Venolia, our coordinator. And for those looking for more information about Northeast Wilderness Trust or the Massachusetts Sierra Club, please visit our websites. I'll put them in the chat after I get done talking and after Shelby gets started. And of course, feel free to make a donation of any size to either Newt and or the Mass Sierra Club. Always appreciated. And we love seeing you all too. So welcome, Shelby. I will now turn it over to you. Thanks for coming.
Thanks so much for having me. And so great to meet you all in the Zoom world. I'm going to take just a second to share my screen here because I do have a PowerPoint. And let's see what this looks like. And all right, can everyone see that? You can just thumbs up me. Great, awesome. Okay, so like Lynn said, I'm Shelby Perry, Wildlands Ecology Director at Northeast Wilderness Trust, and I made this presentation originally a few months ago for my local nature center, and Lynn asked me to reprise it here for you all tonight. So it's a very sort of widely appealing general audiences, fun and playful presentation about the promise of passive rewilding. And so for the purposes of today's presentation, I'm going to introduce myself. So here I am. I am the Wildlands Ecology Director, as I said, but today I will be serving as your there it goes, management planning guide. And probably you all know what I mean by management planning, but just so we're all on the same page, management plan is a document you might put together for any forest, looking usually 10 or 15 years into the future and detailing your goals for that forest. There are lots of goals that you might have from producing wood products, habitat enhancement, non-timber forest products like tree syrups, nuts, mushroom foraging, things like that. These are all really important goals that produce really important forest products and benefits, but there is one more kind of management you might want to plan for in your management plan that's often forgotten or overlooked. And it's a critical piece of the patchwork of land uses in the Northeast, and that is passive management. And that is the kind of management planning we're all going to do today. So I'm getting a little ahead of myself. Whoops. And I got way ahead of myself there because I switched the slide without noticing. But I put together an agenda, and look, I can already cross something off. So I introduced myself, and then I'm going to go through and introduce you. as your management planning guide, I'm going to walk you through outlining what goals might be served by passive rewilding and when you can expect to see results. But before we do that, I have a job for you. So much of what we do as humans is very human centric and with a very human centric lens, which makes sense because we're people and we're really good at considering our own wants and needs. The harder part is to consider things from someone else's perspective. So I'm going to ask you all to do something kind of tricky tonight, which is we're going to try to do some management planning, but from someone else's perspective. And so I'm going to walk you through a couple options, and you're going to pick one that you're going to try to watch the rest of this presentation from that perspective. And then we're going to go through the rest of this agenda. We're going to get to know a piece of land. We're going to talk about our management objectives. We're going to fast forward and kind of look at what might happen with our management planning. And then we're going to kind of talk about what those outcomes are and also any questions you might have. But we're going to do all of that with an avatar. And our first option is a hemlock tree. So I'm going to give you 4 options. This is number 1, hemlock tree. And I realize there are more than just hemlock trees in this picture, but bear with me. Some of these are hemlocks. And if you were a hemlock, let's see, that's supposed to get smaller and it's not. There it goes. So some stats about hemlocks. They're really good at growing in the shade. So this is what I want you to think about when you're embodying the hemlock. You can come up under a full canopy of a forest. Your little seedlings can come up and be really small underneath the forest canopy for a long time. You are a friend to cold water fish because you hang over streams and you keep that water cold and clear. And that's really important because warm, unshaded streams are not very good for fish habitat. You can live to a maximum age of about 600 plus or minus years old. Bob and Monica, you'll note that I updated that. Thank you to your skillful sleuthing. I previously said 800 and that was incorrect. They are in the 600 plus year range for the most part. And they are threatened in our region by an invasive forest pest known as hemlock woolly adelgid that probably many of you have encountered or seen in your rambles throughout the forest. And that's a pretty sad story that kills some of those mature overstory hemlocks over time. Okay, so there's hemlock tree. That's number 1. Next option is a winter wren. Winter wrens, you can pick, so if remember, you're picking one of these. So winter wrens were described by naturalist John Burroughs as having a vibrating tongue of silver for their long and beautiful song. If you haven't heard a winter wren sing, I highly recommend Googling it. You will never forget it, and you'll hear them all over the place. The males will return to the same nesting territories year after year and will build sometimes up to 6, sometimes up to 12 individual nests within that habitat. When the females return, they'll squire them around and show them all the nests and let the female pick their favorite. Lucky males might get 2 ladies to pick a nest in their territory, but then also busy males. And when the females pick a nest, they'll finish it off with feathers and soft moss and do sort of the last, what you might call feathering of the nest before the eggs are laid. They do prefer older forests with shaggy bark, tipped up trees, and lots of other structural features. Winter wrens kind of famously nest in those root wads that pull up when a tree falls over. So when it blows over and its roots pull out of the ground and there's all that sort of gnarly dirt and roots sticking up in the air, they'll build a little nest that kind of hangs between those roots. And the longest recorded lifespan in the wild for a winter wren was about 6 years and 8 months. All right, another option. I wouldn't be a newt if I didn't offer you a newt. So Eastern newt is option number 3 for who you can pick to be today. Eastern newts are the unofficial mascot of Northeast Wilderness Trust. They start life in the water and become terrestrial for their midlife wander. They're sometimes called Kurt Vonnegut phase, where they're on the road. And then they'll return to water and settle down to start a family, although they're not particularly good parents. They just lay their eggs and leave. And they will eat mosquitoes and mosquito larvae, and they can live somewhere, the maximum lifespan, somewhere between 12 to 15 years. So, sort of maybe surprising, newts can live longer than winter wrens. And they can, in that time, go in and out of that orange wanderer phase. Sometimes they'll find a pond and they'll settle down, and then something happens. The pond dries up. It becomes not ideal habitat anymore, and they'll turn orange again and wander on to new territory. And their skin is slightly toxic, which is what that bright orange color is telling you. So that helps protect them from predators. Okay, last one. If you know me, and some of you do, you know that I will never do an entire presentation without including a slime mold. So this one's called honeycomb coral slime mold. And this one is a plasmodial slime mold. That's a soil-dwelling amoeba. I earlier this year gave a slime mold presentation for the Berkshire Green Drinks, and that's recorded somewhere. So if you want to learn more about slime molds, you should look that up. I think there's a link also on our website if you want to find it. These slime molds are often confused with cellular slime molds, which are different. So if anyone's ever told you about slime molds and they said, oh, they're a bunch of little things and they come together and they make one thing that has a fruiting body and that's where the spores are. That's a cellular slime mold. Those are individual single-celled organisms that come together and fruit as one. Plasmodial slime molds are like one big creeping cell. It's a big blob with a bunch of nuclei in it, and it moves around like an animal on the forest floor. It's a predator of other slime molds and fungi and other sort of small soil-dwelling things. And then it fruits like a mushroom. So it moves like an animal, but it fruits like a mushroom with spores. So what we're seeing in that photo that I'm using is the fertile phase. That's the fruiting body. And if we zoomed in really close, we'd see that all over that slime mold fruiting body, there are little tiny stalks, and at the end of each one is an individual spore, and that's how it reproduces. Plasmodial slime molds have been found through scientific experiments to be able to solve mazes and display forms of intelligence, even without what us humans would think of as a brain. And they've been used to do things like model the most efficient route. They put baits in a medium, and they put the slime mold in that matched sort of the major stops of the Tokyo subway system, and the slime mold rebuilt the most efficient route, just like the famously efficient Tokyo subway system. So and I'm going to note they have two dormant phases in their life cycle. So they can, when the spore germinates, they become a little cyst that can dry up completely and be dormant, or it will fuse with another one and start dividing and become a plasmodium that can then also dry up and become a dormant phase. So we don't really have any idea how long an individual one can live, because it might dry up for some extended period and then rehydrate when conditions become favorable and start moving around again. So we don't understand these quite as well as we understand the other options on the list, but I think that makes them more exciting. So just like a video game, everyone needs to choose a character from this list. Whoever you choose as a perspective, I want you to try to embody for the rest of this presentation any one of these guys. And I'm going to point out that all of these are pretty common beings in our local area. You could go out and find these. So whatever you pick, I hope you spend some time with them after this presentation and get to know them a little better. Okay, so back up to the agenda. I love crossing things off. Doesn't everybody just love crossing things off? We did two things. So next up, we're going to get to know the land, and I want you to be looking at it from your perspective, because rewilding is much more interesting in practice than in theory. So I'm going to introduce you to a particular piece of land that we can think about this through, because it just gives us something to sort of sink our teeth into instead of the theoreticals. So whenever we start talking about rewilding, it usually means we're starting from a place that has sort of lost some of its wildness, right? We're rewilding. It's not wild to begin with anymore. This is common. I'm not going to repeat all of our forest history, but I am going to note that in the past handful of centuries, much of the Northeast has gone from mostly forested to mostly cleared and back again. So a lot of our forests are not as wild or structurally complex as they once were. They lack a lot of those characteristics that were once the norm. So here is a typical preserve as it comes to us at Northeast Wilderness Trust. And occasionally we get older ones, and that's always very exciting and awesome. But we play the long game, right? We're taking the long view. So we will take a piece of property that looks like this, and you can see there's some logging history visible on that property there. You can see some skid trails, and you can't see from this satellite photo perhaps, but I can tell you because I have been there that there are stone walls and barbed wire, old fences indicating that there might be some more agricultural history to this property at some point in the last couple hundred years. But still, our whole cast of characters is present. All of you are here. And I'm going to show you where you are. So I put the newt right there in the beaver pond, which I think is where they would eventually want to settle down. I put the winter wren on this little knoll down there in the, let's see, west corner, because there's some older trees and a little bit more structure there. I put the hemlocks down in the south end where there is a little hemlocky ridge. And I put the slime mold kind of up there in the middle because it's a bit wet in there. And slime molds are slimy things. Anything that's slimy needs moisture to live and move around. So I thought I would give it a wet spot. So now that you all know where you are, uh, whoop, there we go. Here are some photos that I took on the property itself so that you can look at it sort of from your ground's eye view. There are a few fairly large trees left behind, like the cedar pictured on the left. There is a cedar swamp on this property that goes sort of along that, I guess, southeastern boundary. And there's a few big old cedar trees left, not a ton. And that leaves some structure for things like wrens to nest. There's plenty of woody materials for slime molds to grow on and newts to seek shelter under. That middle picture is actually a different species of slime mold called wolf's milk slime mold. And it looks like little pink bubblegum balls almost. And you could probably see that one in the woods right now also if you go out looking around. And there's a beaver pond, home to many newts in their aquatic phase and surrounded by a ring of hemlocks because they are not a preferred food of beavers. So that's sort of a common thing you see on the landscape. Those old beaver ponds start to be ringed with conifers because the beavers prefer to eat the hardwood species. So those are the good parts of the property. But by and large, the forests are young and uncomplicated. A lot of the trees are around the same size, not very big. They're just starting to sort of thin out. You can see right front and center in this photo, one of them is dead, and the other ones will start to sort of fill in the gap that one leaves and get bigger. But mostly these trees are all, a couple inches in diameter, not very big, all the same size. So this is the setting that we're thinking about. And this is I didn't say it when we were looking at the map, but the Durin Mountain Wilderness Preserve is where we are. And that is the land. Oh, look, I'm gonna cross them all off again. So next up, my newt and wren and hemlock and slime mold friends, we are gonna work together as me as your land manager to identify our management objectives for this forest. And this is a pretty normal piece of the process anyone might do when they have a new piece of forest land. But I'm just going to start right now by saying we're each going to go through our management goals, but I want to note that each of these species, as I said earlier, is really common in our local woods, meaning they can survive in a huge variety of circumstances. So as we go through this, I want you, as you embody I don't want to call them personalities because they're not people, these perspectives, I want you to be thinking not about what they can handle or what they need to survive, but I want you to be thinking about what their goals might be to thrive in a place. What might these things most prefer the forest that they live in look like? Kind of like what we humans do. When we look at a piece of forest, we say, what do I most want from this piece of woods? And that's what we use when we do our management planning. So we're going to do that, but we're going to do it as our perspectives. So hemlock, what kind of management objectives might a hemlock have? Well, first, hemlocks, it seems kind of counterintuitive, right? All plants are green and they want sunlight to grow. But hemlocks actually kind of want shade. And the reason for that is if it's all sunny, they can't compete. There are so many other things that are going to grow so much faster than them in the sun, they're not going to make it. But in the understory of a shady forest, hemlock can get started and they can hang out there for a long time. And then someday, when something falls over or opens a hole in the canopy, they'll get their moment and they'll shoot up in the way that hemlocks do, which is not particularly fast. And they'll fill that gap and they'll become a nice big canopy tree. So their competitive advantage is being able to outlast things in a shady understory. They want a messy forest floor. There's a couple reasons for that. One is that baby hemlocks are pretty tasty to many large herbivores. And if there's a bunch of stumps and logs and stuff on the floor, they might have a place where they can come up where it's hard for somebody to eat them. They also have pretty small seeds, and sometimes often you find hemlocks with their roots kind of curled around stuff. A lot of times this is actually the result of squirrels who like sit up on something to eat the hemlock cones, and they'll leave a few, and then the hemlock seeds will grow on top of whatever the squirrel was eating on top of. And the roots will kind of go down. So they start on nurse logs is what we call that often. So they'll start on top of something on the forest floor. They also want big trees. They need big trees for the shade. They also can share. There are some studies that show that big trees, especially big trees, like a big hemlock tree in the forest, these trees can preferentially share carbon through their root systems with their own young. So this was done by marked carbon studies where they sort of subjected the trees to marked carbon. And what they found is that marked carbon that was absorbed by it's an isotope of carbon absorbed by the big trees was more abundant in the young trees around them that were related to that big tree. It showed up in all of them, but it was more abundant in the ones that were related to it in its own young. So that's where the term mother tree comes from. They do show some parental care, although it may not look familiar to us. They want dead trees laying down and standing up, snags. And so this comes back to the same thing of what I was saying before with the messy forest floor. And I think I actually swapped those two. So the dead trees, they want as nurse logs and to protect them from herbivores. The messy forest floor, they want because that leaf litter will hold the moisture and the seedlings need that to start. So the duff layer in old forests is really important for seedlings to get started. Oh, look, and I have that too. Spongy moss, moisture, and humidity. So all of that is about keeping little baby plants alive when they're just a little tiny embryo coming out of a seed. They can't dry up or they're dead. So they need all of these things to sort of help them stay in the microclimate that they need until they get big enough to handle what conditions are thrown at them. So that's our hemlock management objectives. And now we're going to move on to our winter wren. So what would a winter wren's objective be? Well, first up is that messy forest floor again. And part of that is the collection of stuff on the ground, places for them to hide and nest, materials for them to make nests out of. Also, moisture, which I think is going to come up again later, is important for their prey, insects. So that sort of messy forest floor is where a lot of bugs will live and breed, and they also want to not dry out, so they need that kind of cover. Dead trees laying down and standing up, snags. These guys nest, as I said, in those tip-up mounds, but also in snags and dead trees, in sometimes the hanging like lichens and bark of old trees. So they need that sort of messy, dead tree complex forest area, especially if this little guy is going to build 12 nests. He's going to need like a whole bunch of places to do that. Uneven terrain, places for water to pool. So why might a bird want water? Because their food, well, because everyone needs water to live, but also because their food breeds in water. So a lot of the insects they eat need water, places for water to pool. And sometimes we call these places where water pools in old forests vernal pools when they fill up and they stay full of water for a while, but there is no sort of full-time stream going through and they dry up completely during part of the year. That is really important for certain kinds of things like amphibians and fairy shrimp and fingernail clams. And these are all specialists that live in those pools, especially because there are no fish in them to eat them. And among those are also caddisflies that breed prolifically in those pools. And our winter wren friend will eat those caddisflies and other insects that might breed in those pools. They need tipped over trees. This comes back also to those tip up mounds. So those trees might not be dead, they might be alive, but when they blow over and they peel up this big mound, our winter wrens are going to nest in there and they're also going to forage on there. And they need those thick duff layers, spongy moss, moisture, and humidity. And it's for a similar reason to the pooling water. They need insects and bugs to breed and move around in the forest for them to eat. They also need that moss to feather their nest and make it a cozy place to raise their young. And then they need epiphytes, which is a fancy way of saying plants that grow on plants. And around here, those are often moss and lichens, especially leafy lichens like lung lichen or oak leaf lichen. And those are the big sort of shaggy lichens that hang off old trees. And these guys will nest in those too. So that's important for them. All right, next up, a newt. So our objectives as a newt, I think we're gonna find some repeats in here. What do you think? Newts need shade. Anybody that's little and porous, has a porous body, needs shade to move around on the forest floor. You don't often see newts out on sidewalks and in open lawns and fields because they will dry up, and being dry is dead in a lot of these cases. So they need the shady, wet forest floor. They need the messy forest floor. You can kind of look at the forest floor around this guy. He's got all sorts of leaf, duff, debris stuff to hide under, to evade predators under and move around, to forage for food. So he needs complexity on the forest floor. He needs dead trees, mostly laying down, but I just use the same objective for all of them. Standing up is probably somewhat less useful. The amphibians go under those logs and spend a lot of time under them, foraging and moving around. So you'll sometimes hear it referred to as turning cover when people, herpetologists, go out in the woods and they look for salamanders. They'll go flip over logs and rocks and things to find who might be living under there, and that's the best way to find some of these guys. The newts are a little bit of an exception to that in that they have this bright orange color, so they can just kind of walk around and no one will eat them because they are slightly toxic, but all of their other salamander brethren hide very effectively under those laying down dead trees. They need uneven terrain and places for water to pool because they do breed in those vernal pools and they do feed on the mosquitoes that breed in those vernal pools and the other insects as well. So they need those seasonal pools where they can breed and also eat other things that breed there. And they need tipped over trees. Those tipped over trees really often make those vernal pools, right? The winter wren needs that root wad that pulls up and is all full of dirt, and they put nests in it. But the newts need where that dirt came from, there's a big hole, and that hole will fill with water, and that becomes a place where they can get wet when they start to dry out, and it holds humidity, holds the water table up, and also can sometimes, in some cases, become a vernal pool that becomes important for them for breeding. And they need thick duff layers, spongy moss, moisture, and humidity. And again, this is a little porous body moving around in the forest. They need to stay in a humid environment, as do many of the things that they eat. Okay, everyone still with me? Last one. We're going to talk about the slime mold's objectives now. All right, what do we think a slime mold wants? Well, they need shade. Just like a newt, but even more slimy is a slime mold. They move around on the forest floor. They're, like I said, they're just one big cell. And this is the fruiting phase that you're seeing in this photo. But in their plasmodial stage, it's called a plasmodium, the one big cell, they are quite literally just slime. And so if you've ever seen a leaf on the forest floor and it has sort of yellow veins of slime going across it, that's a slime mold. That's one plasmodium. All those veins will come back together. It moves by streaming, and so they definitely cannot dry out in a sunbeam. They won't be able to move anymore. They need that moisture to move. They need a messy forest floor. Messy forest floor has humidity for same reason as all the other things. Drying out is dying for slime molds and everybody else. I won't belabor that. They need dead trees laying down and standing up. These guys fruit mostly on wood. Some of them fruit on living plants, but mostly on sort of coarse woody debris. They want to get up high so that their spores will travel as far as possible. And so they'll climb up mostly dead trees because they're moist and wet, so that's easier for them to move up the moist and sort of spongy old logs. You can see in this photo, it's on a piece of old spongy wood, and you can see how sort of translucent and juicy it looks, right? It needs something wet to be able to climb up there. And then once it's up there, it fruits and it makes spores, and those spores fly away and become the next generation. And if you do it always on the ground, your spores aren't going to go very far and you aren't going to get very far. So the higher up you get, the more likely you are to catch a little air current and go a bit further. And they go quite far. In fact, I've read once in a book about slime molds that you can chip the outer dead bark off of any living tree almost anywhere. I'm going to say almost. They didn't in the book, but I feel like it must be an almost. And they put it in a moist chamber and you keep it wet for long enough and a slime mold will eventually fruit in there. That's how abundant their spores are. They're just everywhere. They need uneven terrain and places for water to pool. Again, water in the forest keeps the humidity up, keeps the everything moist. We've all had the experience of walking through like a spongy, soggy, wet old forest where you're quiet, you can't hear anything crunching under your feet, the moss feels soft. Sometimes it even wets through your sneakers because it's just holding all that moisture. And contrast that with when you have an open canopy and you have sun reaching the forest floor. A lot of times when you walk around, and you can feel this in the spring too, in an old forest where it's hardwood and the leaves are all on the ground and it's like spring ephemeral season, everything's crunchy and dry, right? It's all dried out because it can't really hold that moisture. Well, when you have places for water to pool, that can hold some moisture and help things that need that humidity even in those drier times. And thick duff layers, spongy moss, moisture, and humidity, for all of the reasons that I said already, these guys are literally slime. Okay, so I went through this with all of you. Hopefully all of you feel comfortable with your list of management objectives. I, as your management planning guide, compiled a list of all of the things that we want in our final forest. And I don't think I missed anybody's anything. So these are what we want our outcomes to be. These are also conveniently all characteristics of old forest structure. And it's really no surprise that these very common and adaptable species have habitat needs that are congruent with old forest structure because these are the conditions that they all evolved with. They all evolved here in our forests, in old forests. And the many denizens of the northern forest around them, other than these four, also evolved with this forest. If you consider all of these different objectives carefully, and you want your most efficient way of meeting all of these objectives, there's one tool that's going to do everything for us. And what is that management tool? It's time. And time is the main way to develop all of these structures. There are sadly not great shortcuts. There are absolutely shortcuts for some of these, though managers should be wary of the unintended consequences. So, for example, a wren, let's say, those of you that are wrens, you might want to go in with a skidder and pull down some trees to create that uneven terrain and those tip-up mounds that you like to nest in. But in the process, they might disrupt the hydrology with their skid ruts, causing erosion and having drying effects on the forest and draining a vernal pool. A hemlock could decide, I'm going to cut down all the trees around me so that I get released and grow bigger because a big tree is important. And in that process, they might disrupt the very mycelial connections that the hemlock hopes to use to nurture its young. So be wary of unintended consequences of your actions, of your management actions, especially when we're managing for this broad crew of individuals, right? We're not just considering the needs of the wren or the needs of the hemlock. We're considering all of your needs at once. So we don't want to take an action that would benefit one that would harm another. And I've heard someone say, and I repeat it often, but I'm not going to take credit for it because I did not say this myself. Anytime you are managing for anything, you are managing against everybody that doesn't have that need, right? So it might sound great to manage for example, the winter wren, but anytime we take a management action for the winter wren, we're actually managing against everybody that doesn't have the same habitat needs as that winter wren. The same thing happens when we're managing for things like a wood product, right? We're managing for a wood product and we want a certain thing out of our forest. So we're managing against everything that doesn't have the same need as that wood product. And when you're managing for old forest structure, you're of course managing against everything that needs young forest structure. So there's even trade-offs there that I have to acknowledge. So I'm going to talk about forest development stages that I put up on the screen here. I want to start by caveating that these are really rough stages, all according to humans. You all, as newts and wrens and hemlocks and slime molds, probably have your own definitions and slime molds and timelines. Uh, and and I'm just showing you mine because I'm a human. Um, so I put the term old growth up there and I put it in quotes, and I'm going to explain why. I think that's kind of a loaded term. Some people believe that you can't call anything old growth unless it's never ever been cut. I disagree with this definition because it sort of puts a cap on it, right? It says we can never ever have any more of it. Anything that's ever been cut can never again be old growth. And I don't think that's fair. I also think that there was a point in time when much of the Northeast was underneath a mile of ice and there were no forests. And they came back from that, so they can probably come back from us. So I use the term with some quotes around it there, but I am going to use it because I don't have a great alternative. Um, so let's talk about these rough forest development stages. I'm going to kind of stretch this out and I'm going to put us on the map. So when we're talking about tree time, well, actually, let me go back to this one really quick because I didn't say all that I wanted to say. When we're talking about tree time, we're looking at the bottom there on that x-axis. Those are years, and we're looking out to about 700 years on here. And obviously, trees and tree time forests can last longer than 700 years, but we're going to look at sort of everything starting from zero. And in most cases in the Northeast, that means we're starting from a field or a meadow, or perhaps a clear cut, or perhaps bare ground underneath a receding glacier. Whatever it may be, it's pretty blank in the start. So your young forest is going to be kind of up in that 10 to 50 to 60 range. And then you'll see that I have a block there that I'm calling mature forest. The reason I put mature forest there is because mature is often a forestry term, meaning it's ready to be cut down. So most of our forests are mature for harvesting wood products in that sort of 50 to 80, 80 to 100. So I kind of put that like 65, 70 to 100 as mature forest. And then it overlaps a little, and that's what that other green color is the mature forest is overlapping with when you start to develop those old forest characteristics. And that's when you start to get more structure and bigger trees. Sometimes foresters call that over mature or decadent forest, and that means it's sort of past the point where it's most economically viable to harvest, and now you're not getting the maximum return on your investment after it's gotten over mature or decadent. I kind of love that term, a decadent forest. And that's when those characteristics are really beginning to develop. And then that one overlaps a little bit with old forest. I have that at the like 150 range. I start calling a forest old if I core a tree and it's like 140, 150 years old. I'm like, all right, that's pretty old. Not a ton of things get that old, particularly in a landscape that's frequently managed. So I put it around the middle there, and I call old forest going all the way to about 200. And then at 200, I have old growth starting. These are all sort of arbitrary places and numbers. Obviously, natural disturbance regimes and unnatural disturbance regimes can reset these, move things around. You can have young forest in old forest. You might have a patch where a bunch blew down and you have like a little patch of young forest in the middle of an otherwise old forest. So these are always coexisting in sort of a shifting matrix across the forest. But by and large, these are my forest development phases. Now I'm going to put you all on the timeline because what we're talking about here is tree time, but of course you're not a tree. Well, some of you are, but some of you are a bird. And so the winter wren, we talked about their life cycle as being about 6.5 years. So if you were starting at a bare ground or a field meadow scenario in your lifetime, you might not really see much past that. In that first 10 years, you're going to see some trees come in, but it's not going to look like much more than a meadow, maybe a shrubland. If you're a newt and you live 12 to 14 years, you might start to see some little trees, some little ones, pole-sized, coming up in that place. And it might take several generations of you to start to see a real forest. I'm going to put a person on here because I'm a person. And right now I learned the average lifespan of a person in the United States is, fun fact, going down 77 years. And so there I am. If I started a forest, if I was born at the same time a field was abandoned, I might make it to somewhere in that mature forest category. And okay, now here's those of you that are a tree. Where might you be? Well, a hemlock, as we know, can reach 600 plus or minus years. They are my favorite and one of the longer lived trees in our forest. So I'm also going to include hardwood species on here. Oh, but I'm going to do slime mold first. I forgot. I'm doing this out of order. Slime mold I put on here, they have dormant phases. We don't really know how to measure their life cycle, so I consider them infinite. Who knows? Slime molds go on forever. It's hard to establish an average lifespan for an organism like a slime mold. Now I'm going to share my caveat, which is that I put hemlocks on here. They are my favorite and one of the longest lived trees in our area. But most hardwood species are in that sort of 300 to 500 years old is about the maximum age. Some of them not even that. So I did put that on there as well to sort of show the range of our forest tree lifespans. All right, so now we're all on the map. And let's think about me right now for a minute, because you're all looking at this from the perspective of other animals, but I am a person. And the average lifespan of most of our local trees would fit at least 6 full human lifespans in it. So it's not surprising that a human like me might feel like forests can't get very far without my help, because I watch it for my whole life and it just doesn't change that much. But the speed at which forests change just means we don't see that much change in our over the course of what I'll call our observational years. Unless, of course, we go in and we make that change, which we do a lot for wood products, but also to meet other goals, sometimes to try to speed up the development of old forest characteristics. We can make some trees grow bigger faster through management. We can make big dead trees through management, but we can't make time. Human influence looms large in many forests in our region, and it can be hard to even see other perspectives sometimes. We're humans. It makes sense that we look at things from a human perspective. But looking at the world from an entirely human perspective can mean that we miss, or sometimes simply misinterpret, the needs of other beings. Taking an ecocentric perspective, meaning one that does not center human needs, on just some parts of the landscape. Lots of studies and conservation designs suggest somewhere between 10 and 20% makes room for all the rest of life. And you all, as some of that, the rest of life in this right now, would be pretty thankful, I think, to have some places to be. So now I have introduced myself. I've introduced you. I've introduced the land. We talked about our objectives. We got one last thing. We're going to fast forward. So coming back to our patch of land, if our goal is making room for hemlocks and wrens and slime molds and newts, The management tool we have opted to use is time. What can we expect to see in our lifetimes? Well, this forest didn't start at field. It started as a matrix of forest ages from 20 to 30, all the way up to some patches of those bigger trees that are probably closer to 60 to 80. A wren then in its lifetime, if you give it all the time you have, wrens, isn't likely to see the forest get much beyond those ranges. And a newt will only get a little further. Sorry, newts. Much more concerning to them would be making sure the structure that is there stays intact and continues to accrue. And likewise, to make sure the hydrology that's there is not disrupted. Taking management actions to speed up stand development could be devastating for them, leading to the loss of their favorite nest spot or draining the pools that they breed in or that breed their favorite foods. The hemlock, on the other hand, is likely to see old forest structures return to the landscape. Short-term actions aimed at speeding up this process is going to be but a blip on their radar. Hummingbirds buzzing through. While they are slowly and methodically putting on hardwood and building a mycelial network and actions that are aimed at building those structures faster will, if anything, lead to weaker wood and damage their support network. Slime molds are the really interesting one, though, because they represent all of the little species that we just don't really well understand. It's hard to predict how anything would impact them on the grand scheme of things. Actions aimed at releasing a big tree could result in drying that would send them into a dormant phase that could last 5 days or 5 years, depending on how the conditions change. So they're sort of the wild card, right? We don't know how our actions impact slime molds. We understand these other guys pretty well, but we could have impacts on slime molds that we're just not understanding. And that represents an entire sector of life. The vast majority of the species in our forests are in that category, are little things dwelling in the soil and the leaf litter, and we just don't understand them very well. Oh, I put a person on there, but my notes aren't changing. Okay, so I put a human lifespan on there, and that showed, and then I zoomed past it, and that showed where I would be and what I might see. And we can't fast forward, but what we can do is look back for clues about what will happen next. So this is the preserve established in 2020. Here's as far back as I can go in the available satellite imagery for this place, which is 2003. This is prior to the establishment of the preserve. You will note it's also prior to the establishment of the beaver pond, and it is prior to the most recent logging that occurred on this property. Here it is circa 2006. So now you can see this is when that harvest happened. It happened somewhere in between 2003 and 2006. You can really see the changes in the canopy. This imagery is fall, it looks like. That's why we've got some color, and you can see where the evergreens are. Those are mostly cedars and hemlocks down by the road. They left that mostly because it's a swamp. And then the trees that are intact on the I'm going to call that the west side, kind of that point sticking out to the left is the summit of Durin Mountain itself. And so that's just steeper. And you can see they've come up the backside and done some cutting up there, but the steep slopes are pretty intact. Now here that is in 2011. And unfortunately, there's a very big cloud on the day they took the photo this year, but you can see it's getting green again. It's filling back in. Those roads are less open looking. And we got one more, I think, 2013. Here's a note. The arrival of the beavers happened somewhere in between those last two images. We did not have a beaver pond, and now we do. So they came back They are, I call them hydrology heroes. They're going to hold water on this landscape and prevent erosion, which is really wonderful. And here it is circa 2023. We just watched 20 years pass on this property, and we saw a ton of progress. Unfortunately, I don't have photos on the ground from the last 20 years. I only have those ones from, when we made the preserve. So I can't show you the shift with like on the ground photos, but what I can say is that that shift from the open areas to shrubs, then to saplings and small trees, you see the arrival of beavers, the creation of new wetlands, the thinning of some areas of those shrubs and small trees for the dam construction and winter snacks of the beavers. You'd see the start of a shift from fast growing gap filling species like brambles and gray birch to longer lived but still sun loving trees like the aspen, well, I guess birches and aspens I'll put in there. You'll see the accumulation of 20 seasons of leaf litter and organic material. You'd see the work of rebuilding a forest happening. I was part of the team that protected this property as wild, a fact that I'm proud of, even though I will never get to see this forest be old again. I know the hemlocks will, I know the slime molds will because they're infinite. I know that many generations of wrens and newts will benefit from the many ecosystem services, which I'm also putting in quotes because I also don't like that term, this property provides, as will I receive those services from its growing pools of carbon storage and the clean and cool water that flows off of it, to the aesthetic and health benefits of intact forests that surround us. And so back to our to-do list. The only thing left is to discuss. And I have a couple of slides where I'm going to talk about a couple of the most frequently asked questions, and then I'm going to open it up to you just to try to sort of head off some of the ones that I know are bubbling under the surface. So question 1, invasive species. I'm going to start off by saying this is a hard one. I don't claim to have the right answer on this. I did a lot of research. I came to what I think is the right conclusion for newt and for our properties. I encourage you all to dig deeply into this topic and come to the right conclusion for you. What we decided when passive rewilding is that we do not control invasive species at this point in time. There are a couple reasons for this. One, we work at a huge scale, and that would be massively expensive and difficult to do at that scale. We're working on a project right now in Maine that's 11,000 acres. We don't have the capacity to sweep those 11,000 acres free of these invasive species. The other reason I have come to this conclusion is that animals and plants move around on the landscape. They always have and they always will. Nature is not static. Nothing stays in one place forever. We are trying to protect the resilient and beautiful and amazing landscapes of the future. They are not going to look like the beautiful, resilient, amazing landscapes of the past. And protecting a museum of a place that no longer exists doesn't serve anyone. So it gets very sticky and complicated when you start to think about things like rare species that might be pushed off their habitat by these things, or invasive forest pests like that hemlock woolly adelgid that I mentioned way back at the beginning. I'm not going to delve into that too much. I'm just going to say, do your own research, do your own thinking about it, and draw your own conclusions. These are the conclusions that I have drawn. I'm happy to talk to you about it individually, but I don't really want to debate it. Okay, next one. Can you passively rewild an area that has been heavily harvested or clear cut? And like, what does that look like? There's this myth out there that I hear all the time that like, if the forest all grows up at the same time, it's all going to be the same age and they're all going to get old at the same time and they're all going to die at the same time. And then you're not going to have a forest. And I just feel like I need to say right now, that's not how forests work. Trees grow up, they're all the same size, and then like somebody knocks some over, or the wind blows and knocks something over, or a moose walks over it and eats half of them. And then this one gets released and these ones are all still small. And you start to get small, patchy dynamics. That gets bigger as the trees get bigger. Those dynamics get bigger. It might look like all the trees are the same size and they're all going to be the same size to you as a human because you might watch it for 5 or 10 years and think, I need to go in there and do something to let these go. But if your objectives are not wood products where you need to grow the most wood in the shortest amount of time, you don't need to take action to make the forest get structure faster. It will get there. It just takes time. Okay, I think I have two more. This one is scale. Is there a size at which passive rewilding doesn't work? In other words, can something be too small? And I say no. I think it works at many scales. There is a paper that came out a long time ago said 5,000 acres is the minimum functional size for all of the processes and functions of wilderness. And that is true. And so people say to me all the time, well, shouldn't you be working on only 5,000 acre projects? And I say no. 5,000 acres is the size at which you get 100% of the functions of wilderness and wild forests. But 1 acre can give you some subset of those. And it might matter the whole world to this bee whose range might be that 1 acre. So when you're thinking at different scales, you can rewild at different scales. You might not get 100% of the function of wilderness at a small scale, but if you let the edges of your yard go, if you plant native plants in your garden and you let some weeds grow and you don't tend your lawn like a manicured golf course, that's rewilding on a small scale and that has benefits. Last one I got here is a deer browse. What do we do about deer browse? How do we get a forest to come back when deer are just going to eat everything? And this is where I say that messy forest floor is important, right? They're kind of cleaning out the understory right now. What we need is that structure, that messy logs all over the place that deer can't easily navigate. And that's where the trees are going to grow. And that's how we're going to get our forest back. It's going to take time. It's going to be complicated. Deer are a growing issue. They're not going to go away. They're climate change winners. What they really need are real predators, and I am not one, so I can't say anything about that. But I do think we sometimes hear like, oh, if you just let the forest go, the deer are going to eat everything and nothing's going to come back. It's not true. Things are going to come back. That composition will probably shift away from deer's favorite foods over time. It very likely will shift to a lot of invasives potentially. But over time, as you build that structure, you will start to get those tree species back as you get that seed bank back. And I think I'm going to leave it at that and open it up for questions from you. Oh, I had a pretty picture. There we go. Okay. Thank you so much for having me. Thank you to the Sierra Club Forest Protection Team for having me. And I think Celeste said she was going to compile some questions, and I hope you have some. I hope I didn't bore you all to tears.
Thanks, Shelby. That was an awesome and informative and fun talk. And I haven't seen questions in the chat yet, so I will currently take questions by hand raise and also in the chat, so we'll balance both of them. And as a reminder for folks who are raising their hand, we are still recording. So if you feel more comfortable not being on recording, just drop it in the chat. Let's go to Anita.
Sorry. Thank you, Shelby. That was great. I have a couple questions. One, how did you get the satellite images with various periods of time? Is there some website or app I don't know about that I could do that?
Yes, I used Google Earth Time Slider. If you have Google Earth, there's a little tool called the Time Slider. It shows you a timeline. It shows all the years of imagery they have, and you can kind of click back and scroll through them. If I want to go back further, there's I didn't do it here. Sometimes there are sources for aerial photos, like Vermont had aerial photos done statewide in 1962, I believe. Those are not geo-referenced. You have to like dig them out of a map and find your place. But sometimes that's about as, usually there's like a 30s and a 60s. That's about as early as you can go. And the Google Earth time slider will just go basically back to the early 2000s, but that's the tool that I used.
Got it. Great. And I noticed in the chat somebody is mentioning the Middlesex Conservation District has aerial photos of the state. Wow. Very impressive at intervals. And then my next question is about management. So, where I live, there's a couple of forests, and the town, doesn't have the money or is not prioritizing the money to come up with a management plan for its forest. And when that's going to happen, I'm sure at some of these local smaller municipalities, what are other ways either citizens or a park committee can come up with an informed management plan? And I'm wondering, are there different forestry organizations or schools or that people can possibly tap into to help these municipalities come up with a plan for the forests that are under their jurisdiction?
Boy, I'm not sure I'm the best person to answer that. Maybe the forest protection team is better to weigh in on that. I will just say, um, there are often always foresters willing to do it. They need to be paid. And consulting foresters make management plans all day long. That's what they do. You can tell them your objectives. They'll write a management plan. You might be able to work with schools, students. Sometimes teachers will, when people are learning to do management planning, they might be able to do it for cheap or free. But I'm not totally familiar with like who the best resources in your area would be, so I'd have to defer on that one.
Yep, no worry. Thank you. Those are my questions.
Let's go over to Say.
Um, hey Shelby, that was a really nice talk by you. I have a question with respect to deers, I guess, but with like a different perspective to it. Do these rewilding projects help not just deers, but like, all of these animals go back into the forest and like, have their habitat there, then, being on the roads or like the highways and like escaping from their terrains and being hit by, vehicles and things like that. Like, do they have any impact with rewilding, I guess, is my question.
Yeah, so animals that have come out and are kind of used to being around people on roads and in communities, really what happened is less that they came out of the forest and more that we built our roads and communities in their habitat. And so it's I don't think there's any like making them go back. But what we can do is give them the best habitat possible, outside of our towns. Now, white-tailed deer are a tricky example because they are not really old forest specialists. They produce the most numbers in young forests with lots of low, close to the ground forage. Um, I'm not sure the most numbers is what we want for white-tailed deer, right? And same with moose. Like in an old forest system, they just exist at much lower concentrations on the landscape because there's not as much food for them. So that's one way in which the sort of forest condition interacts with those populations. I think the real way to stop having like deer car or to reduce deer car collisions and things like that is to well, I guess I'll give you two ways. One is to have predators back on the landscape like wolves and cougars who keep those populations moving around and smaller. And the other is to do our planning of our cities and towns and roads in a way that takes into account all of the other things that live in this landscape and tries to make our landscape permeable to them. So there are places where we have wildlife underpasses or overpasses where we plan for them to be able to move because even when you have these big wild blocks, it's really important for them to be connected, for them to be able to move back and forth and have gene exchange between those various populations.
That makes sense. Thank you.
Let's go to Bart.
Okay, now since we've dealt with a number of things, uh, there's an alternative to the Google Maps thing, which is Bing Maps. And if you can get, I don't know how you get older ones, but they, for some reason, I believe, take most of the pictures in the winter. And that gives you a lot more information sometimes about what species of trees are growing where and so forth, because certain trees will lose their leaves in the winter and others on and so forth. So the combining that with the Google Maps thing you have will give you a little bit more information. Okay, so that's just a piece of information. The two other things are, if people haven't read the book Crossings, which is about what's called road ecology, you maybe just didn't get into that far, Shelby, I guess. But that's a really good source of information about the issue of animals having to cross the more and more intense network of roads which cover not just the US but the world, and which is causing massive deaths of wildlife. I don't even like the term wildlife, but of beings that are not humans. And of course, it also if they institute some of the things that you were mentioning, having better crossings, then they also cut down on human deaths as a result of accidents with moose and deer and so forth. The last thing is deer have been, in Massachusetts in particular, but in many states, have been growing rapidly because of the widening of corridors for transmission lines and so forth. The areas that they live in, there is much more young forest habitat than there used to be, and it keeps expanding at a rapid rate, partly because of wildlife management and so forth. The idea that we need a lot more young forest habitat, which I think, in my opinion, is nonsense. But it is a huge problem, and we know the deer population is growing pretty rapidly based on the number of collisions with deer. That's pretty good evidence that this is happening, as well as what we see happening in the forests, where large areas where it's very hard. And there have been lots of exclusion experiments. There were some good ones in New York State, in the Letchworth forest area with Letchworth Gorge, where they enclosed certain areas and they grew wonderfully where the deer couldn't get at the understory. But where the deer were allowed to grow, they didn't. And you're right, in the long term, absolutely, things will gradually get to a different state. But yeah, it's not easy, and people don't have much patience compared to trees. And one other thing, that the black, I believe it's called the black gum. They have some of those that get up to about 700 years in age, and it may be the oldest species of broadleaf tree in the US. I mean, all the really big ones and really big, really old ones are gymnosperms, conifers. So anyway, that's my statement as opposed to question. Sorry about that.
That's true. That was a statement. So I'm going to quickly, I realize we are running out of time here, but I'm going to quickly lift one question out of the chat. Mostly there were lots of thank yous for the presentation in the chat. Are you in favor of the Vermont Climate Resilience and State Wildlands Act that would protect state land as wildlands?
As a representative of Northeast Wilderness Trust, I don't take a stance on legislation at all. So I can't say one way or the other in this capacity.
Very fair answer. Lynn, did you have a separate question to close us out there?
Well, yeah, I don't, I hope it's not too long. I was just wondering about your statement, Shelby. First of all, thank you for the absolutely wonderful presentation. I so appreciate it. But I was wondering, you were talking about management plans, and I've just noticed in management plans that they give the reason for that they give for cutting a lot of times is they'll say it's a mature, even-aged forest. And you were talking about how forests just don't age evenly like that. Some things fall down, you have new things growing up, which of course has been my observation in walking in forests. You have some big trees and some little trees. But a lot of times in the management plans, they'll say it's an even age forest, and so we need to go in and knock down some big trees in order to make room for little trees. Can you explain that a little bit? Is that in your realm?
Um, I could take a stab at it. So the way foresters write management plans is they divide a parcel into stands. And so when they say a stand is even age, it means they sort of drew a line around all the trees that are the same age. So it might be part of a larger sort of matrix where some of them are older and some of them are younger, but they're gonna write prescriptions by the stand, and they're going to say, okay, this stand is all even aged, and it might be all middle-aged trees. And a lot of times it's, 50 or 100 acres or something like that. And it could be part of a big area that all came back at the same time, but this is like the even aged piece of it that's left. So it does exist. Even aged stands do exist on the landscape. They definitely happen. There's definitely ways that managers might try to add complexity to them for a wide variety of reasons. It can depend on your objectives. One common thing, if you're writing a management plan to manage for wood products, you don't want even age, because when everything is the same age, it takes a long time for those competitive dynamics to play out to create that complexity. And you're trying to grow wood. So you want to do some thinning, because the trees that remain will grow faster if you reduce that competition that's happening all at once. So a lot of times that's what they're doing. They're trying to skip ahead, right? They're trying to do that sort of natural process of adding complexity really quickly because they have a goal in mind of what that outcome they want. Sometimes they do it because they say they're building habitat. They say, oh, this even-aged forest, it's all gonna grow old at the same time. It's all gonna die at the same time. And that's where I start to feel like it's not all going to die at the same time, right?
That's what they say. That's what they say in the management plan, and I just have a feeling it's actually more for extraction, even though they say it's for like habitat.
I think it comes from that sort of incongruity of human and tree timelines. I think it comes from people watching all of these trees in competition tightly and not, you know, thinking down the line. Some of the nicest older forests that I have seen in parts of Vermont are old fields. They just were abandoned in like 1840, and now they're beautiful old forests. But that's a long, long time. And, when you're a human in particular, you don't want to wait that long. And you also some people feel like they have a real duty, right? Like, we made this and we have a responsibility to fix it. We made this uncomplex forest or this old field that is, this even age stand that has resulted from an old field. And now we have to go fix it and make it better. And I think that there are cases where I might agree with that, and there are cases where I think maybe we're just being a little impatient for the scenario. I think there's a again, it all comes back to your management objectives. What are you trying to get? And if the thing you're trying to get doesn't need to be here really soon, you can always use time to get there. If you're trying to get forest structure, you can always use time to get there, but it's going to take longer. And so they do these actions because they want to speed it up. And that's sort of when I was talking about like the slime molds as a surrogate for all the little things that we don't understand. We do a pretty good job managing for mammals and large forest dwelling animals that we're very familiar with and are well studied. We even do a pretty good job managing a lot of plants. We know quite a bit about the vegetation dynamics of our forests. When you get to fungi, when you get to soil dwelling amoebas and nematodes and all of those little things that live in the soil and the leaf litter, we don't have any idea what the impacts of our management are on those communities, and they make up the vast majority of the species of life. So I feel fortunate in my role at Northeast Wilderness Trust to be able to put some things back on the landscape that are aging in that sort of time scale without those actions to speed it up, where those communities are building over time without being disrupted by active management. I don't necessarily think that's the correct answer for every single part of the landscape, but I do think it's the correct answer for the wilderness preserves that we are creating. And it can be for some areas, but other areas it isn't. It really comes back to your management objectives, which is a little bit of a cop out, but
No, it's not. That was a really helpful answer. Thank you so much.
And I think that's a lovely note to close out on. So thank you again, Shelby, for coming and speaking with us tonight. And I hope everyone has a lovely rest of their evening.